Today I am going to discuss the trick to find the hybridization of any molecule. But before that, you need to remember some points about hybridization. Hybridized orbitals participate for sigma bond formation only. Pi bonds always formed by unhybridized orbitals. Lone pairs occupies hybridized orbitals while odd electron occupies unhybridized orbital. Now come to the trick. If you know the structure of the molecule, then you can use trick 1. For that, you have to calculate number of sigma bonds and number of lone pairs. When you add them, you will get the Z value. If you get Z value is equal to 2, then the hybridization will be SP and geometry will be linear. If Z value is equal to 3, then hybridization will be SP2 and the geometry for SP2 hybridized orbital is trigonal planar. If Z is equal to 4, then sp3 hybridization will be there and the geometry will be tetrahedral. For Z is equal to 5, hybridization will be sp3d and the geometry will be triangular bipyramidal. For Z is equal to 6, hybridization will be sp3d2 and the geometry will be square bipyramidal or octahedral. Now let's apply the trick to find out the hybridization of carbon in methane molecule. First of all, draw the structure of methane molecule. So this is the structure of methane molecule. Now calculate the number of sigma bonds. As you know, single bond is formed by the sigma bonds. As there are 4 single bonds, there will be 4 sigma bonds and there is no lone pair. So the Z value will be 4. For Z is equal to 4, hybridization will be sp3 and the geometry of methane molecule will be tetrahedral. Now come to the next molecule C2H4. This is ethene. Now draw the structure of ethene. So in ethene molecule there is double bond between 2 carbon atoms. And you know double bond is formed by 1 sigma and 1 pi bond. Now calculate the sigma bonds formed by each carbon. So here it is first sigma, second sigma and this is third sigma bond formed by this carbon. Similarly calculate the sigma bond formed by the other carbon. So here this is 1 sigma, second sigma and this is third sigma bond. So the other carbon has also formed 3 sigma bonds and there is none lone pair. So the Z value will be 3. For 3Z value, hybridization will be sp2 and the geometry will be trigonal planar for each carbon. Now come to the other example, PCl3. Now first of all draw the structure of PCl3 molecule. In PCl3 there are 3 sigma bonds and 1 lone pair. So there are 3 sigma bonds and 1 lone pair. So you will get Z value is equal to 4. So the hybridization will be sp3 and the expected geometry is tetrahedral. But you have to remember one thing. If lone pair is there, lone pair distorts the shape of the molecule since they are invisible in the geometry, as I have discussed in my previous video of hybridization. Now draw the structure of tetrahedral molecule. So phosphorus is present at the center and these are 3 Cl molecule and 1 lone pair occupies the one corner of tetrahedron. But as this lone pair is not visible in the geometry, this molecule looks like pyramidal. So the actual structure of PCl molecule will be pyramidal, not tetrahedral. Now come to the PCl5 molecule. First of all, draw the structure of PCl5 molecule. As there are 5 sigma bonds and 0 lone pair, so the Z value will be 5. For 5, hybridization will be sp3d and geometry will be triangular bipyramidal. So far we have discussed the trick in which you know the structure of the molecule. But if you don't know the structure of the molecule, then you can use trick 2. For trick 2 also, you have to calculate the number of sigma bonds and number of lone pairs to get the value of Z. As you don't know the structure of the molecule, here you have to calculate the total number of valence electrons of central atom. If there is negative charge, then you have to add 1 electron for each negative charge. And you have to subtract 1 electron for each positive charge. Let's apply the trick for ammonia. In ammonia, nitrogen is the central atom. Its atomic number is 7 and it has 5 valence electrons. So first of all, draw 5 valence electrons of nitrogen. Hydrogen is monovalent atom, so it will utilize single electron of nitrogen to form sigma bond. So here 1 sigma bond, this is another sigma bond, and this is third sigma bond. So there are 3 sigma bonds, and these 2 electrons will be considered as one lone pair. 3 sigma bond and 1 lone pair. When you add them, you will get Z is equal to 4. For Z is equal to 4, hybridization will be sp3 and the expected geometry will be tetrahedral. But as there is one lone pair is present, the geometry of ammonia is not tetrahedral but it is pyramidal in shape. Now come to the next example. Next example is NO2 negative ion. Here nitrogen is the central atom and it has 5 valence electrons. As there is one negative charge, you have to add one electron for each negative charge. So you will get 5 plus 1 is equal to 6 valence electrons. Now draw 6 valence electrons of nitrogen. Here there are 2 oxygen atoms. Oxygen is a divalent atom. So it will utilize 2 electrons of nitrogen to form double bond, in which one bond is pi bond and other bond is sigma bond. Similarly, other oxygen also utilize 2 electrons of nitrogen for the formation of one sigma and one pi bond. So here you will get 2 sigma bonds and these 2 electrons will be considered as one lone pair. So here you will get Z value is equal to 2 plus 1, that is equal to 3. For Z is equal to 3, hybridization will be sp2 and the expected geometry will be trigonal planar. So here this is the triangular planar geometry in which nitrogen is present at the center. One oxygen occupies one corner and other oxygen occupies the another corner, while third corner is occupied by the lone pair. But as they are invisible in the geometry, the shape of molecule you will get band shape. So the NO2 negative ion is bent in shape. Now come to NO2 positive ion. Here nitrogen is the central atom and it has 5 valence electrons. As there is one positive charge, you have to subtract one electron for each positive charge. So here you will get 5 minus 1 is equal to 4 electrons. Now draw these 4 electrons of nitrogen. Oxygen is a divalent atom. So it will utilize 2 electrons of nitrogen to form one pi and one sigma bond. Similarly, other oxygen also utilizes 2 electrons for the formation of one sigma and one pi bond. So it will form 2 sigma bonds and there is no lone pair of electrons. For Z is equal to 2, hybridization will be sp and geometry will be linear. Now come to the other example, O3. In O3, oxygen is the central atom and it has 6 valence electrons. So first of all, draw 6 valence electrons of oxygen. Here oxygen is a divalent atom that is bonded to central oxygen. So one oxygen will utilize 2 electrons of oxygen for the formation of one sigma and one pi bond. Other oxygen also utilizes 2 electrons for the formation of one sigma and one pi bond. So in this way, it will form 2 sigma bonds and there is one lone pair. So you will get Z is equal to 2 plus 1 is equal to 3. For Z is equal to 3, hybridization will be sp2 and the expected geometry should be triangular planar geometry. But as there is one lone pair present, if this is the triangular planar geometry and one oxygen is present at the center, other occupies one corner of the triangular planar geometry and third oxygen will occupy the other corner. Third corner is occupied by the lone pair, but as they are invisible in the geometry, shape of O3 will be band. In the next video, we are going to discuss problems based on hybridization.